Hi, boys and girls. So today we are starting with an introduction to exponents. And we are going to start this lesson by watching a quick video before we move on.
Hello again, everyone, and welcome to this lesson where we are going to explore the basic concepts behind exponents. Now, as always with our lessons, we're going to start out by guiding our thinking with a question, and that question is, what is an exponent? But first, let's chill by the pool for a moment. Let's also consider the addition of a tropical drink, which would not be complete without a mini umbrella. What does this have to do with math? Well, exponents work like this. We have some number that's called our base value. That's like the actual drink in the glass. Exponent is like the little umbrella up at the top. So now we can extend our thinking to looking at some numbers. Imagine if we had 3 with a little 2 up at the top right-hand corner. This notation says that 3 is the base value and 2 is the exponent. We should also note that exponents are also called powers. So for this example, we could say 3 to the power of 2 or 3 raised to the power of 2. So now mathematically, what does 3 to the power of 2 even mean? So this is how it works. We always start off with the base value, in this case 3. And since it's being raised to a power of 2, we will be using the number 3 2 times. And anytime we work with exponents, our operation is going to be multiplication. So we're multiplying those 2 3's together. Another way to say it is 3 times 3, which we know equals 9. So 3 to the second power is equal to 3 times 3, which is equal to 9. And now we can extend this thinking. We know that 3 to the second power equals 3 times 3. We're multiplying 3 twice. 3 to the third power equals 3 times 3 times 3. We're multiplying 3 times. And, of course, 3 to the fourth power is going to equal 3 times 3 times 3 times 3, or 3 multiplied 4 times. So now we can stop and make a conclusive statement, and that statement is that an exponent tells you how many times the base value is multiplied by itself.
Okay, so we're going to look at some notes about exponents. So sometimes you'll see that a dot, we've talked about this before, is used to represent multiplication, okay? So you'll use an exponent and a base to show repeated multiplication. Repeated is something that happens over and over, right? So the expression shown down here, it shows us 1, 2, 3, 4, 5. There's a number 7 being multiplied 5 times. So the number 7 is the base, which is the number that's being multiplied, and the exponent is how many times it's being multiplied. 1, 2, 3, 4, 5. Okay, let's keep looking. So here's another example. The number 2, which is my base, because that's the number that I'm multiplying, is being multiplied 1, 2, 3, 4, 5 times. So again, my exponent is 5. The number 2 is being multiplied 5 times. Now, before we continue on, I just want to show you how to make an exponent on a Google Doc. So, for example, if I have 10 and then I want to put the exponent 3, I'm going to go to Format, which is up here, Text, Superscript. See how it shows an X with a little exponent with a 2? You're going to click on Superscript, and if I want to add the exponent 3, it looks like a 3, okay? So that's how you add an exponent. Let's do it again. So notice this is actually important that when I started typing, everything is still small like an exponent. So I'm going to go back to format, text, superscript again, and then that'll reverse so I'm back to my regular font. So if I wanted to do 6 and then an exponent of 8, I'm going to do format, text, superscript, 8. Okay, and then again to reverse it and to get out to my normal size, format, text, superscript, then you can see my cursor is back to its original size. Okay, so let's keep looking. So when we write exponents, exponential form is when you have a base and an exponent. And repeated multiplication is when the multiplication is written out. So 5 is being multiplied 3 times. 1, 2, 3. So here's an example. It says 30 to the 4th power, or 30 4 times. 1, 2, 3, 4. Now here, we had the number 12 being multiplied 6 times. So 1, 2, 3, 4, 5, 6. Because that's all it's asking when it wants to see your repeated multiplication. Let's do another example. Okay, notice that I'm small up here next to my exponent, so I need to go back to my normal size. 4 is my base, so that's the number that I'm multiplying, and it's going to be multiplied 10 times because my exponent is 10. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, now if you look, it's the opposite. Now I need to write it in exponential form. So the number that's being multiplied is 2. And how many times is 2 being multiplied? 1, 2, 3, 4 times. So I need an exponent of 4. Just like that. Here's an example it's done for you. The number 5 is my base because I am multiplying the number 5. And I'm multiplying the number 5 1, 2, 3, 4, 5, 6, 7, 8 times. So my exponent is an 8. Let's do one more example down here. Number 34 is my number being multiplied. So that is my base. And how many times am I multiplying the number 34? 1, 2, 3, 4, 5, 6, 7, 8. Also an exponent of 8. So remember format, text, superscript. There's my exponent 8. Now, some exponents are special and they have different rules. So when you have a base raised to the first power, so an exponent of 1, it's always just equal to the base. So 4 to the first power is 4. 598 to the first power is 598. 37 to the first power is just 37. So it's just equal to the base. Now, a base raised to the 0 power, 4 to the power of 0, it's always going to equal the number 1. So that's a funky trick right here. 4 to the power of 0 is 1. 598 to the power of 0 is 1. 37 to the power of 0 is 1. Okay, it's a rule. You just have to remember these 2 rules. They're special, and they'll be here as notes for you to refer back to. Some special names. There's 2 special names that we use, squared and cubed. So if you have 3 to the second power, you can also say 3 squared, which is 3 times 3, because it's the number 3 2 times. So 3 to the second power is the same thing as 3 squared. The second special name is cubed. 3 to the third power is 3 cubed. 3 times 3 times 3. These are just 2 special names that you're going to have to remember. Okay, we'll look at them again in an example. So it says, write the following in exponential form. So my answer should have an exponent. An example that's done for you, it says 5 to the 4th power. 5 is my base, to the 4th power, 4 is my exponent. 5 to the 4th power. 4 squared, now remember squared is the exponent 2. And 4 cubed, remember cubed is the exponent 3. And then the last example is 6 times 6 times 6 times 6. So it's the number 6 being multiplied 1, 2, 3, 4 times. So my exponent is 4. Now some examples we did together. 8 to the 5th power. So 8 is my base. And to the 5th power means that my exponent is going to be a 5. That's my 5th power. 7 cubed. 7, remember cubed is special for the power of 3. So I need an exponent, format, text, superscript, an exponent of 3. Cubed means 3. Exponent of 3. How about 7 times 7 times 7 times 7 times 7 times 7? My base is going to be 7. And then remember, I asked myself, how many times is it being multiplied? 1, 2, 3, 4, 5, 6. So I need an exponent of 6. My last example is 12 squared. 12 is my base. And remember, squared was a special name for the exponent 2. So I'm going to need 12 with the exponent of 2. Okay? Now, write these equivalent expressions using repeated multiplication. So all it wants is you to write it out using repeated multiplication. So 9 to the 3rd power is the number 9 being multiplied 3 times. 1, 2, 3. So 9 is my base. 4 to the 5th power, 4 is my base, so I am multiplying the number 4. How many times? Well, my exponent is 5. So there's 1, 2, 3, 4, 5 times. This would be the equivalent expression using repeated multiplication. The next one, 3 to the 6th power. 3 is my base, and it is being multiplied 6 times. So 1, 2, 2, 3, 4, 5, 6 times. 1, 2, 3, 4, 5, 6. And 3 is my base, so 3 is the number that I'm multiplying. In the last example, 10 is my base, and I am multiplying 10 4 times. So 1, 2, 3, and 4. The last thing that we're going to do is now to find, once I have it either in my exponential form with my exponent or my repeated multiplication, I need to find an answer. So the example here is 6 to the 3rd power. So 6, 3 times. 1, 2, 3. Now the way we solve this is doing 6 times 6, which gives me 36. And then after I multiply 6 times 6 and get 36, I need to multiply it by one more 6. So 36 times 6 is 216. Okay? Remember, these numbers are going to get big, so you either have to do long multiplication or use a calculator. And it would be great to do the multiplication on a piece of paper and then just check your answer with a calculator. So 2 to the 7th power is 2 times 2 times 2 times 2 times 2 times 2 times 2, 7 times, right? So 2 times 2 is 4. Then times another 2, 4 times 2 is 8. Times another 2, 8 times 2 is 16. Times another 2, 16 times 2 is 32. 32 times 2 is 64. And now 64 times 2, my last 2 is going to give me 128. So if you did that on paper or whether you use a calculator, you should get the same answer. Another example was 4 to the 5th power. 4 times 4 times 4 times 4 times 4, 5 times, right? So if I did 4 times 4, that would give me 16. And then if I multiply 16 times another 4, that's going to give me 64. 64 times 4 is 256, times another 4 gives me 1024. Okay, you have to make sure you're being organized on your paper while doing your multiplication. And then again, double check with the calculator. So last example is 3 to the 4th power. So my base is 3, and I'm going to multiply 3 together 4 times. So 1, 2, 3, 4. Now if I want to find the answer to that, I'm going to do 3 times 3 is 9, right? So I did 3 times 3 is 9, times another 3. So 9 times 3, we all know, is 27. And then times my last 3, I have to do 27 times 3. And that equals my answer of 81. So 3 to the 4th power is 81. Okay? Now that we've listened to the notes, let's look at our exit ticket. Our exit ticket is 8 questions that asks us to do a few different things. So write an equivalent expression using repeated multiplication. So your answer should be repeated multiplication. Remember, that looks something like this. That's repeated multiplication. Write the following in exponential form. So you should have a base and an exponent. What is the value of the following expression? Write the following in exponential form. So if it asks for exponential form, you should have a base and an exponent. What is the value of the following expression? 23 to the 1st power. Find the value. This means you actually need to multiply it out, similar to what we did on the very bottom here. It wants to find the value. You really need to solve it. And the last question again is write it in exponential form. So you should have a base and an exponent. Okay? You are more than welcome while you're doing your exit ticket to refer back to the notes that we did here on these pages. And you may also go back and use this video to help you as well. Okay, look back at the examples, look back at what he was teaching. Okay?